Welcome to the second part of 4.3 to 4.4 notes. We're looking at the mean value theorem again. Now we had a mean value theorem for derivatives. In order to make it work, you had to first make sure that your function was continuous on the closed interval from a to b and differentiable over the open interval from a to b. If that's true, then there's a value in between a and b where the instantaneous rate of change was the same as the average rate of change. Okay, the slope of the tangent line equaled the slope of the secant line. Now with the integral, it's the same basic concept. First of all, we have to be continuous on our closed interval, once again, because you can't find the area under the curve if you're not continuous. There exists a c value in between a and b, so same concept, such that your area under the curve is equal to, and you'll notice this is a height, this is the base. So it's saying that there is one rectangle that is a height of f of c that will represent the entire kooky, crazy area under the curve. Okay, so that's basically what that's stating for us. And more specifically, when you're looking at the average value, they're saying that f of c, that y value, is going to be that total area divided by b minus a. So a total divided by the number that there are, that is what we do for average. We add up everything and then we divide by how many there are. So we've added them all up, we divided by how many there are. So it is a true average. Now when they're looking for average, sometimes they want the x value where the average occurs, and sometimes they want the actual average value. Now when they want the actual average value, we get to stop after we find 1 over b minus a times the integral from a to b, because that is that average value. That is the y value. But when they ask us to find the values of c that are guaranteed by the mean value theorem, they're wanting to know where. That's the x's. So what we have to do is actually set our f of c equal to our 1 over b minus a times our integral. And they actually want us to solve for that c. Okay? So looking at number 10 here, we are continuous in between 1 and 3. We have a problem at 0, but that's not where they're asking us to look for things. So f of c, and I'm going to leave it f of c for just the moment, 1 over b minus a times the integral from a to b of our function. I'm going to go ahead and put that in power form so I'm ready to go. I have 1/2. I am going to integrate this, so I'm going to have 9x to the negative 2 divided by negative 2. I'm going to take that from 1 to 3. I'm going to rewrite it before I start plugging in some numbers here. That's going to be negative 9 over 2x squared. If you plug 3 in and then you subtract plugging in the 1, you're going to get your 1/2 times this integral, that area under the curve, is going to equal 4. So this whole 1 over b minus a times the integral from a to b of f of x dx is actually 2. Well, that's what f of c is equal to. Well, f of c is just 9 over c cubed. Okay, that's f of c. You're just plugging c in for all the x's. Now, I want to know what that value of c is equal to. So I'm going to cross multiply, so I get 9 equals 2c cubed. I'm going to solve for c cubed, so I've got 9 over 2 equals c cubed. Now I want to solve for c, so I'm going to cube root both sides. Now this doesn't look very attractive, but it is accurate. It is in between 1 and 3. It is exact. So that's what we're going to leave our answer as. We do not have to rationalize. That's our final answer. So it's not too bad, but you do have that extra step of solving for your c. Okay, we're going to do the same thing up here. We're going to look at our f of c. It's going to equal our 1 over pi over 3 minus a negative pi over 3, so that's going to be a plus, times our integral from negative pi over 3 to positive pi over 3. of cosine. Make sure you're writing everything out. Well, f of c, I'm going to wait to write out f of c, because if you put c's in for all the x's, you get cosine of c, which looks like some bizarre word. Okay, so when I simplify this, I'm going to have 1 over 2 pi over 3. Well, 1 over 2 pi over 3 is 3 over 2 pi. I'm going to integrate cosine, which is sine. I'm going to plug in the pi over 3 first, and then the negative pi over 3, which is going to give me, if you plug that in your calculator, it's going to give you square root of 3, because you get sine of pi over 3, which is square root of 3 over 2, minus sine of negative pi over 3. Well, sine of negative pi over 3 is negative square root of 3 over 2, so the negatives cancel and you're adding. So you have square root of 3 over 2 plus square root of 3 over 2, which is square root of 3. Now I'm going to plug that in my now I'm going to find my f of c, which is cosine of c equals 3 square root of 3 over 2 pi. Now, in order to find out what my values are, I need to find out what c is equal to. To solve for c, I'm going to have to inverse cosine. Oh my goodness, how exciting is this? So c is going to equal my inverse cosine of 3 square root of 3 over 2 pi. I'm plugging that whole thing in. Now this 3 square root of 3 over 2 pi, it's positive, so that means I am looking in quadrant 1, quadrant 4. Looking at how they gave us our interval here, they went positive this way, negative this way. So we're going to do the same thing. If I put this in my calculator, make sure you are in radians, please. If I hit inverse cosine and I put all of this in my calculator is going to give me 0.597 when I round it to 3 decimal places. Well, I know that this is 0, this is pi over 2, so we're going to pi over 3. Pi is a little bit bigger than 3, so divided by 3, it's a little bigger than 1. So 0.597 is going to be perfectly fine. Since they went to the fourth quadrant in the negative direction, we are too. So we'll have a plus and a minus 0.597. That is in radians. Okay, so we found our C's. These are those answers. Now please try this in your calculator to see if you can get your 0.597, because if you can't get your calculator to give you the correct answers, we need to go over that in class. So please come see me if you cannot get this plugged in your calculator correctly. I will show you the magic. Now when we get to this little guy, it's a little different. They're just wanting to know that average value. Well, first of all, I don't like the way they gave me the equation. I don't know why they have to be so difficult. Remember that we have to do our own division. We don't have a product rule. We don't have a quotient rule. So we'll have to do this ourselves. So 4x squared divided by x squared is 4. 4 divided by x squared is 4x to the negative 2 power. So simplify that before. That way, when you're finding f of c, which is what they're asking us to find, that's our y value. So that's that y value, that's that average value. Then we're just going to do 1 over b minus a, so 1 over 3 minus 1 times the integral from 1 to 3 of my function, new and improved. Don't forget that dx. When you're writing it out, they want to see it. That's going to be 1/2 times the integral of 4 is going to be 4x. The integral of 4x to the negative 2 is going to be 4x to the negative 1 divided by negative 1. Taking that from 3 to 1. I'm trying not to skip too many steps just because I don't want to freak you out. So that's 4x. That's going to be negative 4 over x. Plug the 3's in, then plug the 1's in, multiply by 1/2. Your final answer should be 5 1/3. So check that out, plug it in your calculator, see if you get 5 1/3. If you don't, we're going to have to check that out together. So the mean value theorem, this is your average value. That is your f of c. That's going to equal your 1 over b minus a times that integral. Total area divided by how many there are, or what there is. Okay, so it's just an average value. See you tomorrow.